This is how-to videos, circular motion example 2B, speed and acceleration. So, Scott is thinking about being a fighter pilot, and he's heard that in general they're not supposed to go faster than 5 G's worth of acceleration when they're making curves and turns. And if we're going at 950 meters per second, what type of turning radius are we talking about? So we imagine our plane, something like this, and it's going around and it needs to turn around like this. And of course, this is not at all to scale, but here is the turning radius. So we're trying to figure out how big that is. So let's see. We said that acceleration is going to be 5 G's, and we know that a G is 9.8. So let's go ahead and multiply. So 5 times 9.8 meters per second squared. We have acceleration is 49 meters per second squared. And the velocity, the tangential velocity, we said is 950 meters per second, which is, I mean, depending on elevation, that's about 2.5 or 3 in the Mach scale. So about Mach 2.5, Mach 3. We are looking for the radius, and we are looking for the period. Now it's the period to do a U-turn, so that's only half the way around, but we'll look into that shortly. So makes sense that we have the acceleration and the velocity squared, and we're, I'm sorry, the velocity t, and we're looking for r. So that means we're going to use acceleration centripetal is equal to tangential velocity squared divided by r. You don't actually need to write in the t if you don't want to. It's not a big deal. Rearranging, we are going to get r is equal to v squared divided by acceleration centripetal. So I would be plugging in 950 meters per second. That whole thing is squared, divided by the centripetal acceleration, which we calculated to be 49 meters per second squared. And we go ahead and tap that in, tap, tap. R is equal to a pretty big number, 18,418 meters, which is somewhere around, well, it's somewhere around 18 kilometers, a little more than that, of course, but that's quite a large distance. Now you say, well, why in the world is it so large? Did we make a mistake maybe? Well, looking at our equation here, we do have r being proportional to v squared, and because the centripetal acceleration is a fixed value, we're just going to say r is proportional to v squared. So when we have a small v, that's going to be a very, very small r. But look, when the whole squared, just a slight increase in the velocity means a large increase in the r. 950 meters per second is pretty darn fast. So we're talking about large distances here. So that's completely reasonable. Okay, let's go ahead and move on and go ahead with our time. We can solve this a couple of ways, but I think it would just be easier. Say the tangential velocity is 2 pi r divided by t. So rearranging, we get t is equal to 2 pi r divided by the tangential velocity. However, remember we are making a U-turn, which is only half of the circle. So that pretty much just means t for this U-turn is going to be equal to pi r divided by v. So we got rid of the 2 because we're only doing half of it. So we go ahead and plug in. We have 18,418 meters times pi divided by 950 meters per second. Tap that into our calculator, and we get about, period being for half of a turn, about 60 seconds. Now, that seems like a long time, but we are talking about a pretty large object going really, really fast. So Obviously, we can make a U-turn much faster than that by when we're walking or when we're driving, but this is going almost 1,000 meters per second, which is just huge. So it's going to take a long time to be able to do it safely.